Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Advanced Transformer Architectures. Beyond Standard GPT BERT. Imagine you're building a super smart app that needs to understand or create human language. Standard computer programs read text word by word, like a person slowly sounding out each letter. Transformers are a special kind of AI brain that can read the whole sentence or paragraph at once, understanding how all the words relate to each other. Think of it like a very fast, very smart editor who can see the big picture of your entire document instantly. From a developer's perspective, a transformer is a powerful neural network architecture that has become the backbone for many modern language AI applications, letting your code see context like never before. When we talk about transformers, you often hear about GPT, generative pre-trained transformer, and BERT, bidirectional encoder representations from transformers. GPT is like an amazing creative writer. Give it a prompt, and it can generate coherent, human-like text. BERT is more like an expert reader and summarizer. It's brilliant at understanding the meaning and context of text you give it. These are incredibly powerful, general-purpose tools, almost like the Swiss Army knives of AI. For developers, these models are fantastic starting points for tasks like chatbots or search engines. But just like a Swiss Army knife isn't always the best tool for every specialized job. Like building a house, sometimes you need something more specific. While GPT and BERT are revolutionary, they have limitations. Imagine trying to use a huge, powerful desktop computer for a tiny task on your smartwatch. Sometimes, standard transformers are 1. Too big and slow. They need massive computing power, which is bad for mobile apps or real-time responses. 2. Limited context. They can only remember a certain amount of text at a time. If you feed them an entire book, they might forget the beginning. 3. Single-minded. They are mostly designed for text. What if your app needs to understand images, sound, or even code alongside text? As developers, we encounter unique problems, and sometimes the standard solution isn't the most efficient or effective one. This is where specialized transformers come in. Problem: standard transformers struggle with very long documents like legal contracts, entire books, or huge codebases. They often forget information from the beginning as they process later parts. Solution: long context window transformers. Like Longformer or Big Bird, these are designed with clever tricks to process much longer sequences of text efficiently, allowing them to remember context from thousands of words away. Analogy: if a standard transformer reads a chapter at a time, a long context transformer can read and understand the entire novel, remembering details from page 1 when it's on page 500. For a developer, this means you can build applications that truly understand and analyze extremely lengthy texts without losing crucial information, enabling more sophisticated document analysis or code understanding. Problem: the powerful GPT and BERT models are often enormous, requiring powerful servers and lots of energy. This makes them unsuitable for devices with limited power, like your smartphone, or for applications needing lightning-fast responses. Solution: efficient transformers, like mobile BERT or light transformer. These are engineered to be smaller, faster, and more energy efficient while still performing very well. They achieve this through various optimizations, like reducing the number of internal layers or simplifying calculations. Analogy: think of it like comparing a powerful desktop computer, standard transformer, to a highly optimized, compact laptop or even a smartphone. Efficient transformer. Both run programs, but one is designed for portability and lower resource use. As a developer, this opens up possibilities for deploying AI directly onto mobile devices, embedded systems, or within real-time applications where speed and resource conservation are critical. Problem: most transformers are built just for text. But the real world isn't just text, it's images, sounds, videos, and more. How do we build AI that understands all of these together? Solution: multimodal transformers. Like Clip or DALL-E's underlying tech, these architectures are trained to understand and connect information from different modes, like text and images simultaneously. They learn how concepts described in words relate to what they see in pictures. Analogy: imagine a translator who can not only read and write different languages but also understand sign language and interpret visual cues. Putting it all together, for developers, this means you can create revolutionary applications like searching for images using text descriptions, generating artwork from written prompts, or building AI that can understand a video by looking at the visuals and listening to the audio. It's about bringing AI closer to how humans perceive the world. The world of AI is constantly evolving, and beyond standard transformers are a testament to that innovation. As a developer, understanding these specialized architectures isn't just about knowing fancy names. It's about having a richer toolbox. Just like you wouldn't use a hammer for every construction task, you now have a deeper understanding of when to use a general-purpose transformer, like GPT, BERT, and when a specialized one, for long contexts, efficiency, or multiple data types, might be the perfect fit. This knowledge empowers you to build more intelligent, more efficient, and more innovative AI applications that tackle complex, real-world problems effectively. The future of AI is specialized, and you're now equipped to be part of it. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.